So guys, today in this session, we will be talking about the most important questions and concepts for our upcoming CSIR NET and the GATE physics exam. So everything we will be considering here in the session will be very much important. But before continuing the discussion about these important things, I would like to tell you something about the latest offer which is going on Unacademy, which is just gonna be there for limited period. Means it's just valid from 16 to 21st February, and to grab this offer, you can use and apply the code that's Anjali Alive as mentioned here on the screen. So by using and by applying this code, you will be able to get the discount in the total subscription amount, that is flat 20% off, and all the details about it have been shown here on the screen too. Also guys, you can share this information with your friends, those who want to take the subscription, so that they will not miss it and they will also be able to grab all these important like benefits. They will be able to get them, and even in upcoming days, so many new courses by the top educators will be starting on Unacademy, so they will be able to check out the important courses and the classes by the top educators too. Even you can proceed further if you have not taken the subscription till now, and let them know about the code as well, that's Anjali Alive as mentioned here on the screen. So you will be getting so many benefits whenever you will be taking the Unacademy Plus or the Iconic subscription, and that's how everything will be helping you a lot to take your preparation to the next level. Now let's continue the discussion. Hello Anuradha. Also guys, even now the notes are available on the learning app, which will be helping you a lot to take your preparation to a very good level. Okay, now let's continue the discussion. At any point of time, if you will be having any doubt anywhere, you can surely mention it. I'll be discussing those points and we will be considering all these important things this way. Okay, so let's continue the discussion now, and I hope the session will surely be helping you to practice most important questions based on most important concepts. Okay, so let's continue. It's going to be the first question I'm going to give you right now in the session. Okay, and there will be questions we will have from so many different concepts, so many different topics which are most expected in your exams. So that's how we will be taking the discussion forward. Also, in upcoming days, we will be having so many important sessions too. Don't miss them. Try to join those sessions as well. Let me just write the first question for you. It's here. Consider a system in the unperturbed state described by the Hamiltonian that's going to be H naught is equal to 1001, comma, that's going to be the system is subjected to a perturbation of the form that's going to be H dash is equal to delta, 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 and delta, where delta is very much less than 1. The energy eigenvalues that's going to be of the perturbed system using the first order perturbation approximation are, options are 1 and 1 plus 2 delta. Next is 1 plus delta and 1 minus delta. Next is 1 plus 2 delta and 1 minus 2 delta. Next is 1 plus delta and 1 minus 2 delta. Try it now and let me know as you will get it done. I will be starting the poll too, and as anybody will keep on getting the answer, they can select their answer in the poll. If in case there will be any doubt you will have, we can surely talk about it. But if it will be getting clear to you, that's great. So check it out and let me know as you will get it done. Otherwise, in just some time, I will be continuing the discussion and I will be talking about it. Nobody has selected the answer till now. Next slide is here. No correct answer is there till now. Very good, Anuradha. That's great. If guys you want me to change the slide, you can even tell me that. Very good, Rajat. That's great. So, two right answers we had. Okay, guys, just two answers are correct there. So what I'm gonna do now, okay, I think there is going to be something different. Just a second. All right, let's continue. So actually, in this case, what's going to happen? And rather, for tomorrow, chances are less. While I will let you know, like whenever it will be, as I have told you about today's session. Okay, so that's how I'll be telling you about the other session as well. Clear? We'll try to inform you that way. Now let's continue, guys. Let me just explain this one, that how it's gonna work and how you will be able to get the answer for this question. So actually, in this case, you are going to have this part given to you. That's consider a system of the unperturbed state described by the Hamiltonian. The Hamiltonian is given corresponding to unperturbed state. Means when the perturbation was not included, not involved in the system. Okay, the system is subjected to the perturbation of the form, that is H dash is equal to delta 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 delta, where delta is very much less than 1. The energy eigenvalues of the perturbed system using the first order perturbation will be what? So using the first order perturbation, and what will be the energy eigenvalue when the Hamiltonian is given? So we all know that H psi is equal to E psi. Okay, so energy is the eigenvalue of Hamiltonian. That's what we know. Once you know that energy is the eigenvalue of the Hamiltonian, in that case, what will happen? In that case, to find that eigenvalue, what you will be doing? You are having unperturbed part and the perturbation which has been applied, both given to you. Now, if you know about one property of the matrix, that whenever your matrix is going to be the diagonal matrix, like just the principal diagonal elements are non-zero and other elements are 0 0, so its eigenvalues are equal to the principal diagonal elements. Means for the first matrix, the eigenvalues are 1 and 1. Done? And the other property we know, whenever our matrix, a square matrix is in such a way that the rows and columns are the scalar multiple of a particular row and a particular column. So like here, so in that case, what will happen? It's going to be, you are going to consider the, let's say, the eigenvalues are the trace comma 0 0, means trace is 2 delta here, because the sum of these two will be traced, which is 2 delta comma 0, because it is 2 by 2 order matrix, so you will be just having the two eigenvalues associated with it. Next thing, what you have to do, you just have to take the sum of these two parts. So 1 plus 2 delta and 1 plus 0, that's giving you the energy of first order correction to energy. Okay, so that's 1 plus delta and 1. So where it is 1 plus 2 delta and 1, you just added the unperturbed part eigenvalues with the perturbed part eigenvalues, and that's how you got the final answer. Please tell me if in case there is anybody having any doubt, we can talk about it then, and if everything is clear, that's great. So you can let me know that whether everything is all right and clear to every one of you or not. If clear, I can give you the next question. That's great. We are ready for the next one then. It's here. Let's see how many of you will be getting the right answer for this question now. It is a particle of mass m is subjected to a potential that's going to be V as a function of x and y, which is equal to half m omega square x square plus y square, and we are having x lying between minus infinity and plus infinity, and y lying between minus infinity and plus infinity. Okay, so the state with energy, that is 4h cut omega, is G fold, this is G fold degenerate, the value of G is what? That's what they're asking you to find. And since there are no options, it's like any type question. Okay, so what you need to do, you need to answer it on your own. Just in the comments you can write your answer, or initially you can say done, and I will ask you to tell me what is the right answer according to you. Then you can just mention it, or you can write it if you want. Okay, anyway, but you have to tell me. It will even help you to boost up your confidence if you will be getting the right answer, or will help you to know about the mistakes you can make in the similar type of questions. So let's do it this way and tell me what will be the right answer according to you. Okay, we will talk about it. Very good, Vikram, that you have tried. Waiting for more reply. Just Vikram has replied till now. Very good, Anuradha. Very good, Rajshri. That's great. And the right answer is, let's talk about it. Actually, it's a 2D case. That is X and Y. Very good, Kalipara. So if we are gonna talk about, I'll be calling you Kelly. Is that okay? You can even tell me like the right pronunciation. I think I am not able to do that. Okay, let's continue. So actually, if I'm gonna talk about it, this is a 2D case. Okay, when it is a 2D case, in that situation, our energy in case of 2D is nx plus half h squared omega for x part, and ny plus half h squared omega for the y part. Okay, so if we can see that the coefficient of x square and y square are same here, so in that case what will happen, I can just combine those, nx plus ny plus 1 half plus half will be 1 h squared omega. That's how I'm going to get the overall energy value. Now the next thing is, if I'm going to talk about the next part, that is nx plus ny, I'm going to write as n. So I'm getting n plus 1 h squared omega. So when we are having the energy value given to us, our initial value is showing us the n. Okay. And for the isotopic harmonic oscillator, there is anisotropic one and there is isotropic one. When it is isotropic one, okay, for 2D case, your degeneracy is going to be equal to n plus 1 for whatever state you want to find it. So when you compare this way, you get the n plus 1 is equal to 4, and that's how your degeneracy for this case is 4. So it is a 4-fold degenerate. The value of G is 4. Is that clear? And even if somebody doesn't know about this approach, so to get 4, how many possibilities you can have? For example, you can take 2 0 0 2. Okay, you can take 1 1. Okay, and the next you can have is 2 1 and 1 2 1 and 1 2, because you want 4. And then you can have 1 3 0 and 0 3. So this is how 4 possibilities you had, and that tells you that it's going to be the 4-fold degenerate. Okay, even with the direct approach you get the same, and with this approach you get the same. Let me know, is it all right and clear? 4 is the right answer, right, Anuradha? So those who have got something else, they need to have a look at this part. While those who have said 4, their answer is correct. So very good, Rajshri, and very good, Kelly. In this case, is everything clear till this point to everyone? Can we go for the next one? Yes. Which approach you want me to repeat? See, you had the Vxy given to you as half m omega square x square plus y square. Okay. You know in general its energy is nx plus half h squared omega x plus ny plus half h squared omega y. But if you will see, omega x and omega y both are equal to omega in this case. So which means I can write it to be nx plus ny plus half is 1 h squared omega, because omega x and omega y both were equal to omega. Done. Now you want to find the energy to be 4 h squared omega overall. And you know that for harmonic oscillator your n values start from 0. So in this case what will happen? You can consider it to be 0, like you want it to be 4 now. So what combination the values of nx and y supports that? It's going to be nx and ny can be let's say 1 and 2. Okay, then plus 1 is already there. Then you are putting the nx value as 1, ny value is 2. Or you can put it 2 and 1. Okay, or you can consider 0 and 3, because 0 comma 3 plus 1, that is 0 plus 3 plus 1 is also 4. 3 comma 0, okay, you are just adding them. So these are the 4 possible combinations which will be giving you the value 4 h squared omega. Hence the degeneracy is equal to 4. Did you get it? Let me know. If in case there is any doubt, that's like something you can ask. But if everything is clear, that's great. We can go for the next question then. That's great. And the other approach was, if you know about the degeneracy formula for the isotropic 2D harmonic oscillator, that is n plus 1. Okay, so with that if you compare, we call it n. So n plus 1 value already given to us is 4. That is the another approach which is directly giving you the answer 4. So anyway, you can just proceed further and you can get it. Tell me if in case there is anybody is having any doubt. But if it is clear, I can give you the next question. Tell me, are you ready for the next one? If there is doubt, you can mention it. Okay, that's great. Vikram, are you ready for the next question? That's great. Okay, let's go for it. Consider a system of 8 non-interacting identical quantum particles of a spin 3/2 in a one-dimensional box of length L. The minimum excitation energy of the system in units of pi square h square upon 2ml square. Still you are having time and you need to write its answer. I'm not gonna give you the options, so it will be a digit, okay, and you need to tell me what it is according to you. That's how we are just gonna have this question. Try. Also guys, just I need to show you the initial slide once, which is regarding the offer. So as per the latest offer, you can get flat 20% off on CSIR UGC net subscription. The offer is just valid from 16 to 21st February. You have to use and apply the code that's Anjali Live as mentioned here on the screen to grab this offer. Since it's a limited period offer, you can even share this information with your friends too if they want to proceed further to do their best preparation under the guidance of top educators. Even now, the notes are available on the Learning app. Along with the sessions by the top educators and the most important courses, these notes will even be helping you. So one more thing is in upcoming days, so many new courses by the top educators will be starting on Unacademy, which will be helping you a lot to take your preparation to a very good level. You can grab it now. Now, have a look at this. Once done, either mention done or start writing your answers in the comments. Okay, got it. But we'll be declaring whether it's the right one or not. But that's great that you have tried. That's good. That's good. Very good, Kalipura. Very good, Rajshri. That's great. Guys, you have tried and soon you are going to know about it whether your answer is correct or not. Let's wait for others' reply as well. I'll be explaining each and everything about it. Okay. Very good, Anuradha. We had the three different answers till now, waiting for more, and we'll be continuing the discussion after that. Okay, I'm gonna continue the discussion. Even if anybody will be getting the answer now, they can mention it in the comments. Okay, and let's continue. So basically, guys, the first thing you have to observe in this question when you will read it, they have given you the information about the spin, which is 3 by 2 for the particle. So in any such case, what we do, we try to find the number of particles we can have in one particular state in any such situation. So that is going to be 2s plus 1, which is 2 into 3 by 2 plus 1. That's how you can consider it. It's going to be 4, maximum 4 particles you can have in one particular state. Okay, anytime if you have the spin given, you will be finding the number of particles which can be there, the maximum number with the 2s plus 1. Okay, now let's go for next point. So that's going to be the minimum excitation energy you have to find of the system in units of pi square h square upon 2 ml square. That's great, Anuradha. Now, if I'm going to talk about this one, so how many particles you had? 8 particles. Now you have to consider the system, that is 1D box, and its length is what? L. The minimum excitation energy. Now what is the excitation energy? The energy any particle needs or require to go to the higher energy level. So first of all, as per the basic arrangement, 4 particles can be in the lower energy state, which will be n is equal to 1, and the 4 particles can be in the higher energy state, which is n is equal to 2. Because it's the 1D box system, the n values start from 1. For the formula I'll be using here, which is L square pi square h square upon 2 ml square. So in this case, 4 particles are there in the ground state, so n is equal to 1 square pi square h square upon 2 ml square, plus again 4 particles are in the n is equal to 2 state, which is going to be 2 square, which is 4 pi square h square upon 2 ml square. That's how you can get it. It's going to be 4 4s are 16 plus 4 20 upon 2. Okay, pi square h square upon ml square. That's how you can have it. If I'm going to talk about the next situation, they have asked like what will be the excitation energy required. So for excitation energy, I have to see that what is going to be the higher energy, okay, and how I can get it. So for that case, I'll take 4, 3 and one particle I'm shifting on the higher energy level. Okay, so it's going to be n is equal to 1, n is equal to 2 and n is equal to 3. This is what the next possibility I have taken. Okay, which means that when I will send a particle to the more higher energy level, then what can be the total energy in that case? It's going to be 4 into n square pi square h square. That will give me just 1 square pi square h square upon 2 ml square, plus 3 into 4 pi square h square upon 2 ml square, plus 1 into, that's going to be 9 pi square h square upon 2 ml square. What you are getting from here, can you please tell me? It's 4, 3 4s are 12, 16, 16 plus 9, that's going to be 25. 25 you are getting from here, which is the excited state energy. You just have to take the difference of this case energy with this case energy to get the excitation energy. Means how much energy is needed to go from this level to this level, means this system to this system. So that's going to be your 5 pi square h square upon 2 ml square. So your right answer is 5. Is that clear? Because you have to write it in units of this. That means just you have to write down the number that is it there. Any doubt anybody is having? If yes, you can mention it. If no, I will be giving you the next question then. So please let me know, what do you think? Did you get it or not? Or everything is clear? If yes, we can go for the next question. Are you ready? That's interesting one. Next one. Any doubt? Any doubt anybody is having? Any doubt? Nobody is having the doubt there. Okay, your next question is waiting for you then. The degeneracy of the third energy level of a three-dimensional isotopic quantum harmonic oscillator is, options are 6, 12, 8 and 10. You can try it. Even I will be starting the poll, so you can select your answer in the poll, whatever will be the correct answer according to you. And whenever you are just gonna get it. Very good, Anuradha. Very good, Vikram. That's great. Very good, Rajshri. Very good, everyone. Waiting for more reply, and then I'm gonna continue the discussion about it too. The degeneracy of the third energy level of a three-dimensional isotropic quantum harmonic oscillator is third energy level. Third energy level. Level means this is one level, this is another level, this is another level, this is another level. So n is equal to 0, 1, 2. The first level, whether it's ground state, it's first level, it's second level, it's third level. So third level is corresponding to n is equal to 2 for the harmonic oscillator. And excuse me, if you know about the degeneracy for the 3D isotropic case, it is n plus 1 into n plus 2 upon 2. So n is equal to 2 there, you will be getting 3 plus 4, 3 into 4 upon 2, which is going to be 3 into 2, which is going to be 6. Hence, this is how you can get it. This is the formula for the 3D isotropic harmonic oscillator case. Okay, very good, Mohammed. Very good, everyone. So let's keep it this much. Any doubt anybody is having? If yes, let me know. And if there is any doubt you will have, just mention it. Otherwise, I'm gonna give you the next question. Please mention it, guys, if you didn't get something. Otherwise, next question is even very much interesting and going to be important concept too. So have a look at this. The Hamiltonian for a quantum harmonic oscillator of mass m in 3 dimensions is h is equal to p square upon 2m plus half m omega square r square, where omega is the angular frequency the expectation value of r square in the first excited state of the oscillator in units of h squared upon m omega rounded off to 1 decimal place is dash. So you have to find the answer and you need to mention what do you think is going to be there. Okay, that's how we will be considering it. If you will not get it, I will surely let you know, but yeah, want you to answer it first of all. Waiting for your reply, and after that I will even be continuing the discussion. Very good, Anuradha. That's great. Just in some time, you can even start writing your answers in the comment section. Yeah, it's you. As anybody will keep on getting the answer, just mention it in the comments. Yes, Anuradha, you can. And that's great. You asked for it before writing the answer. That's great. That's very good, Anuradha. Very good, Rajshri. I have a trick for all of you guys. Look at this. There is harmonic oscillator system. The expectation value of position and expectation value of momentum corresponding to any nth state for harmonic oscillator is 0. But the expectation value of position is square and expectation value of momentum is square is not 0. So it will be related to, like, you know, the energy formula for the harmonic oscillator n plus half. It's going to be n plus half in both the cases. But you know, in general, momentum is equal to mv. Okay, so in that case, v is multiplied, m is multiplied together. So in this case, m h cut omega, and in this case, h cut upon m omega, because momentum formula is similar to that multiplied term, so it's multiplied here. In this case, m omega is in the denominator. Did you get it? That's the way of memorizing these expressions, and I think it seems to be quite easy, and it's easy to keep in mind, and we cannot make mistake after knowing about it exactly. So it can help you a lot. Did you get it exactly what I have said? Same way, when you will be considering any position square term, expectation value, that is y square z square. Okay, so what you have to do in this case, it's going to be, see, they have given you have to find the expectation value of r square. So for r square, it will be simply x square plus y square plus z square. Okay, r square is equal to x square plus y square plus z square. Now the thing is, if we are going to talk about expectation value of r square, it is simply expectation value of x square plus y square plus z square. Now the next thing is, you will write here for this one nx plus half h cut upon m omega. For this one, ny plus half h cut upon m omega. For this one, nz plus half h cut upon m omega. That's how you can consider it. But what they have asked you, to find the expectation value of r square in the first excited state. So first excited state value, how you can find it? That's going to be, for the first excited state, you will be having the ground state nx, ny, nz 0, 0, 0 for harmonic oscillator. For first excited state, it will be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and anything you can put. So one of them will be 1 and other two will be 0, 0. So it will give you 3 by 2, 4 by 2, 5 by 2. 5 by 2 h cut upon m omega. Just after, you will take either 1, 0, 0, 0, 1, 0 or 0, 0, 1. So that's how you are getting 2.5 h cut upon m omega. So that's how you're getting option, just 2.5 as the answer. Any doubt? If he has just mentioned it, if clear, that's great. So this is how you can easily solve any such type of question, and it is the most simple and easy way to consider and get the answer for such type of questions. Tell me, are you ready for the next one? It's Vikram. If in case there will be any doubt, you can surely ask that. We can talk about it. This will be added. Okay, so for the first excited state, nx, ny, nz values will be either 1, 0, 0 or 0, 1, 0 or 0, 0, 1. So when you are putting any of these values, you are getting 5 by 2 after adding all the above expressions. Just focus on nx, ny, nz and half. Okay, that's how you can consider it. That's great. Tell me if in case there will be any other doubt anybody will have. And if it is clear, Then your next question is waiting for you. Let's go for that. If there will be any doubt at any point of time, you can ask. The question is, suppose Hamiltonian of a conservative system it's 1 0 0 and it's not the plane, it's going to be the coordinates you are taking for x and x and y and z, the values for them. So suppose Hamiltonian of a conservative system in classical mechanics is h is equal to omega x p, where omega is a constant and x and p are the position and momentum respectively. The corresponding Hamiltonian in quantum mechanics in the coordinate representation is, options are minus iota h squared omega, not actually every day but some of the days, delta upon delta x minus half, minus iota h squared omega, x delta upon delta x plus half, next is minus iota h squared omega x delta upon delta x, and the next one is minus iota h squared omega upon 2 x delta upon delta x. You can start working on it, guys, and let me know as you will get it done. I will even be starting the poll, so you can select your answer in the poll as you will get it. Try, and let me know as you will get it done. Oh, it's here, Rajshri. Actually, the poll part was on top of the message section, so I was not able to see your message earlier, but just drop it down. Very good, Anuradha. That's great. Very good, Rajshri. Two correct answers till now. We'll be explaining it too, don't worry. Excuse me. Okay, basically in classical mechanics, we consider just the coordinates, but in quantum mechanics, we deal with the operators. Okay, so in quantum mechanics, the sequence, the order matters a lot. But in classical mechanics in general, like you write the order like anyway, and it doesn't matter. Okay, so here, if I'm going to talk about it, it's basically going to be just a second. See, suppose Hamiltonian of a conservative system in classical mechanics is h is equal to omega xp, where omega is a constant and x and p are the position and momentum. Okay, so in that case, what will happen? The corresponding Hamiltonian in quantum mechanics in the coordinate representation we need to find. When classical one you will write as h is equal to omega xp. What you can do, you want to write it in quantum, so you will try to write both the coordinates, means both the orders xp as well as px. So for that you will multiply with 2 and divide by 2. So omega xp plus px I can write that way. Okay, because it's even going to be the same thing. 2 xp we had, and it was classical mechanics part. Now I want to write the quantum section with it, so I'm just trying to include everything I can. Done. Now the next thing is, you know, p is equal to minus iota h cut delta upon delta x. That's the operator we are going to have. So what we will do, we are going to operate h on psi now, and on both sides you have to take it. So when you're just going to consider it on both sides, what will happen? It's going to be omega, and minus iota h cut I'm going to take outside because that's just a constant. Okay, so minus iota h cut you are just going to have there. What we had at this place, omega upon 2. Okay, done. And then we are just having xp, that is x delta upon delta x, and then plus delta upon delta x of x, and then psi x I'm taking here. Psi is a function of x. On both sides you can write it as psi x. Now next thing, so minus iota h cut omega upon 2. Now when you will operate this derivative on psi x, so it will be delta psi upon delta x plus delta upon delta x of x psi x, means first term as it is, second term differentiation. So this is what you will get, plus plus second term as it is, first term derivative, that is x, will be giving you 1. That's how you're just gonna get it. You will get 2x delta upon delta x plus 1. So if you will see, is there anything something like that you already had? 2x delta upon delta x, but that 2, if you will take inside from this section, what will happen? It will become just x delta upon delta x plus 1 upon 2. So where it is? It's in option B, hence option B is the correct option. Please tell me, is it all right and clear or not? If in case there is any doubt anybody is going to have, please let me know. And if everything is clear, that's great. So just mention it if in case there is something not clear or somewhere there was doubt. We can surely talk about it. But if everything is clear, we'll go for the next question. That's great. Let me just give you the next one, guys. Let's take this one. If Lx, Ly, Lz are the components okay, and rather you can share it. Of the angular momentum operator in 3 dimensions the commutator Lx with Lx, Ly, Lz may be simplified to options are iota h squared Lx, Lz square minus Ly square, then option B is iota h squared Lz, Ly, Lx, 2 iota h squared Lx, 2 Lz square minus Ly square. 0. Try it now and let me know as you will get it done. We'll be talking about it. I'm going to start the poll too, as anybody will be getting the answer. Select your answer in the poll. Oh, it's okay, Rajshri. Once you will get the exact answer, you can tell me in the comment section too. That's great. Very good, Anuradha. That's great. Just in some time, I am even gonna start the discussion about it, guys. So if I'm going to talk about it in this case, what will happen? In this case, you can see you have to find the commutator bracket of Lx with Lx, Ly, Lz. So if you will go with the detailed approach of working on this part, you may find it's going to be too much time taking, but the way I will tell you and the way we will be solving it right now will be making it quite easy. So Lx with Lx, like combination, will give you something? No, it's 0. Lx with Ly will give you something? Yes, iota h cut Lz. Lx with Lz will give you something that's going to be iota h cut with a negative sign, and that's going to be Ly. So what we will do, we are going to see first term, first combination 0, second combination iota h cut. Lx is present first of all there, then Lz square you will have because Lz into Lz. Then plus sign, then you are getting minus iota h cut. So let's put the negative sign in between. So minus iota h cut, I will be having the Lx Ly present first of all, and Ly once again will give you Ly square. So that's going to be my iota h cut Lx Lz square minus Ly square. That's how you're reaching to the final answer. But you have to be careful about one thing here. What is that? You can write it as Ly square minus Lz square. Let me just see, did we make some mistake somewhere? Let me just check out the sign part. Xy will give you z, so it's positive. Then it's xz will be giving you negative, so that's how you are just gonna have this. So Ly square is negative. Oh, that's correct, it's in option A. We have already taken that negative sign, right? So we have got it. Now one more thing I want to say, that if you are going to just observe what I have done here, you will be getting that it's the same sequence I'm following. When I'm taking Lx with Lx, I got 0. Okay, let's leave it. But Lx with Ly was giving me this. So I will be keeping this value at the center place only. I'll initially write this Lx, then I will write Lz. So I get this. Then when I'm considering this Lz one, so firstly I'll write these two, then I will write minus iota h cut Ly. So that gives me this. We are just going to combine these two parts. Tell me if in case there is any doubt anybody is going to have, we can talk about it. Otherwise, this is how you will be able to get the answer. If in case there is any doubt or difficulty anybody will have, let me know. That's great. This is the previous question answer we have already done. Thank you so much, Anuradha, for sharing this image. This is the same we were considering just now. And yep, it's the part of same question we had. Okay, now let me know if in case there is anybody having any doubt, we can consider it and we can talk about it too. This is again the previous question's answer. Thank you so much, Anuradha, for sharing these images. It's okay, Anuradha. This one at the end we will just be observing it. Can I give you the next question? Are you all ready for the next one? It's a consider the two lowest normalized energy eigenfunction Yes, and Radha will be just observing it. Okay, and whatever doubt you will have, you can even mention that. Of a one dimensional system, they satisfy degeneracy को in general. I'll let you know whether it's multiplicative or additive. That's what you need to know. Okay, so like in general, whatever do with the degeneracy, that's what you will consider. So I'm gonna confirm it to you. Where alpha is a real constant. The expectation value of the momentum operator in the state psi1 is. So options I'll be writing. It's here, Anuradha. We'll talk about it. I think in your question they have shown multiplication of space 1 and space 2. Okay, so maybe there you have to consider the multiplication of these two. क्वेश्चन स्टेटमेंट के अकॉर्डिंग अगर दो सिस्टम्स को कंबाइन किया है, ठीक है, तो देन यू हैव टू गो फॉर इट. अगर वो एक ही सिस्टम की बात कर रहे हैं देन तो यू डोंट हैव टू कंसीडर एनीथिंग लाइक दिस. So when you will read the question, you will exactly get to know that what they are asking you to find. If we are going to talk about this part, it's going to be if two fermions having a spin s is equal to 3 by 2 are in one dimensional box, okay, of length a, if its energy is this much, if the wave function psi total, psi is multiplicative in nature, the corresponding degeneracy will be. So that's what you have to find. And I think it's just directly based on the formula. Even you are not multiplying it or not like adding it, you're just simply going to consider 2s plus 1 to the power n, which is a direct formula here, and that's going to give you the answer. Huh. Yeah, you know the general formula, so you're not doing anything. There are not even two systems, is not even something like which is relating two different parts. So you are just in general use the formula, okay, and you are getting the answer for this. And generally we are having the questions which give us the answer directly with the use of these formulae we are already having. And anytime if you even have to do something like the multiplication and all, so in that case आपका क्वेश्चन स्टेटमेंट से आपको आइडिया लग जाएगा, पता चल जाएगा कि क्या करना है, किस टाइप से एक्सपेक्ट किया गया है उसमें. वेरी गुड राजश्री, दैट्स ग्रेट. Very good Anuradha, very good Rajshri. If in case there is anybody having any doubt, we can talk about it then. So basically guys, if you will see as per the question statement, they have mentioned consider the two lowest normalized eigenfunction energy eigenfunctions psi naught x and psi 1 x of a one dimensional system. This satisfies psi naught x is equal to psi naught star x, okay, and psi 1 x is equal to alpha d psi naught upon dx, where alpha is a real constant. The expectation value of momentum operator you have to find in the state psi 1. So what will happen in this case? This is showing you the psi naught x is equal to what? Complex conjugate of psi naught. Okay, so which means it's a real wave function you had here. So when it's a real wave function, it means that you will have the expectation value of momentum corresponding to the real wave function equal to 0. Initially they defined it for the psi naught x. So you got to know like, okay, when they have defined it for the psi naught x, its psi naught is going to be a real wave function. But then you have seen that psi 1 is also dependent on psi naught. So then you got to know like, okay, alpha is real there and psi 1 will also be real because it is dependent on alpha and psi naught. Tell me if in case there is any doubt. And one statement we all know, that is that the expectation value of momentum corresponding to the real wave function is 0. So that's how your option B is correct. That's how you will be able to get it. Let me know if in case there is anybody having any doubt. We can talk about that then. And if everything is clear, that's great. Done? So that's what you have to consider. I'll be giving you the next question now. If in case you will have any question or query, you can just mention it. In a potential, Vx is equal to A delta x minus A. Its wave function that is psi x is continuous everywhere, the discontinuity in d psi upon dx is at x is equal to a is, options are 2m upon h square a psi x or psi a. The next we had is a psi a minus a. Then C option is h square upon 2ma, and the D option is 0. Try it now and let me know as you will get it done. I'm even going to start the poll. You can select your answer in the poll once you will get it done. Done? Try. Let me know as you will get it done. And you can select your answer directly in the poll. Also guys, in upcoming days we will have more important sessions. We will be doing more important topics, concepts and tricks and tips discussion in the sessions, so you all can join them. Okay, and I'll soon inform you about the upcoming classes too. And here on Unacademy live CSIR UGC net, we will keep on having more and more important sessions too. So very good, Rajshri. Very good, Anuradha. Okay guys, let me just even explain this one, that how you will be doing it. So actually in this case they have mentioned a particle in one dimension is in a potential, that's Vx is equal to a delta x minus a. Its wave function psi x is continuous everywhere. So they have mentioned psi x is continuous everywhere. So you have to find the discontinuity in d psi by dx at x is equal to a. Okay, so what you will be doing in such type of questions, when they talk about the wave function, potential and the energy, we go for the Schrodinger equation. Okay, so that's what we will be using here as well. When you will write it as per the given situation, it will be minus h square upon 2m and d2 psi x upon dx square and plus a delta x minus a and psi x, that's going to be equal to e psi x. This is the equation I have just mentioned right now. I'll be putting the values here, like I have put the v value. Okay, that is a delta x minus a. Now what we will do, they have already given us that the psi x is continuous everywhere, so we are just going to integrate it. We will be taking a like point That's a very small distance epsilon. So we will take a point A because they have asked us to find it at x is equal to A. So A minus epsilon to A plus epsilon, that's how we will integrate. Okay. Again A minus epsilon to A plus epsilon. And same thing you have to consider here, A minus epsilon to A plus epsilon. Once you're going to do that, what will happen next? The next thing will be that you are just going to consider the integration part. So this will become d sine by dx, and this will become give you the sine a, because this is going to be continuous, but at the same time you are integrating it with the Dirac delta function, so it's giving you sine a. So a sine a you got from here. On the other hand, you will get 0, and this is going to be minus h square upon 2m d sine upon dx. Okay, plus this equal to 0. That's what you have got. What you have to do next thing is you will be applying the limits, that is a minus epsilon to a plus epsilon, and this difference between the d sine upon dx values will be giving you the answer for the discontinuity, which will be minus 2ma or plus 2ma upon h square into sine a. So that's how you will be able to get your answer that's matching with option A, and that's how you are getting your right answer. Let me know if in case there is any doubt anybody's gonna have, we can talk about it, but if everything is clear, that's great. So we will be keeping it this much right now in the session, guys, and if everything is clear, that's going to be good. In अगर integration limit infinity to plus infinity ले तो अनुराधा, एक्चुअली जब भी आपने 11th-12th स्टैंडर्ड में भी कॉन्टिन्यूटी डिसकॉन्टिन्यूटी वाले क्वेश्चंस दिए होंगे ना, एक पॉइंट दिया होता है आपको इस पॉइंट के अराउंड डिसकॉन्टिन्यूटी चेक करनी होती है। तो आप क्या करेंगे कि माइनस एप्सिलॉन मतलब एक छोटी सी डिस्टेंस लेते हैं, इधर लेते हैं ए प्लस एप्सिलॉन मतलब थोड़ा सा बस, तो जिस पॉइंट के अबाउट चेक करना होता है उसके लिए कंसीडर करते हैं, ठीक है। दैट्स हाउ वी विल बी कंसीडरिंग इट. Now guys, let's keep it this much in this session, and I hope each and everything will be clear to all of you. So as in the starting of the session, I have told you about this part, guys, that the latest offer which is going on right now, you can grab it, or even if any of your friends want to take the subscription and they want to start the preparation, you can share this information with them too. And we are going to keep it this much right now, and anytime anybody will be taking the subscription can use and apply the code that's Anjali A Live as mentioned here on the screen, and they can grab the offer as well. They can save a lot by grabbing this offer, and in the upcoming days so many new courses will be starting, so they can even start their preparation under the guidance of top educators in all these important courses. Even now the notes are available on the learning app, which will be helping them to take their preparation to a very good level. Let's keep it this much. The offer is just for limited period, okay, so you can grab it or even let your friends know about it. They can use and apply the referral code that's Anjali A Live to get the discount in the total subscription amount. Thank you so much everyone for joining this session.